A $500,000 tractor, fully insured, parked in a field, gone in under 20 minutes. No operator error, no fuel spill, no obvious ignition source, just a modern tractor with modern electronics doing what nobody in the dealership ever mentioned was possible. And the part that should concern every farmer running late-model equipment right now, this is not the first time. And the fire investigators are pointing at the same system every single time. Stay with me, because what we are about to walk through applies to every modern tractor in your shed right now, regardless of brand. Let's start with what actually happened, and what the fire investigators found. A Fendt tractor caught fire during field operation. The fire originated not from the fuel system, not from an exhaust leak, not from operator negligence. The investigation pointed toward the emissions control system, specifically the components surrounding the diesel particulate filter and the selective catalytic reduction system that every Tier 4 final tractor built after 2014 is required to carry by federal EPA regulation. Every major tractor brand built after 2014 runs this same emissions architecture. Fendt, John Deere, Case IH, New Holland, Kubota, all of them. This is not a Fendt-specific problem. Fendt's name is in the title because this specific incident generated documentation and investigation records that allow an honest analysis. The underlying risk is industry-wide. Here is what that emission system actually is, and why it creates a fire risk that did not exist on tractors built before the emissions regulations arrived. The emissions system every modern tractor carries. Tier 4. Final emissions regulations, enforced by the EPA starting in 2014 for large agricultural equipment, require every high-horsepower tractor to run two specific after-treatment systems. First, the diesel particulate filter. The DPF captures soot particles from exhaust before they exit the stack. As the filter accumulates soot, it must periodically burn it off through a process called regeneration. During regeneration, exhaust temperatures inside the DPF system reach 1,000 to 1,100 degrees Fahrenheit. That is not a typo. Over 1,000 degrees Fahrenheit, sustained, inside a system mounted on the tractor frame, surrounded by hydraulic lines, wiring harnesses, crop residue accumulation, and in many cases dry grass and chaff that has packed into every available cavity over a working day. Second, the selective catalytic reduction system. SCR uses diesel exhaust fluid, DEF, to chemically convert nitrogen oxides into nitrogen and water. The SCR catalyst also operates at elevated temperatures and involves its own set of sensors, injectors, and control modules that add complexity and heat sources to the emissions package. During a DPF regeneration cycle, the system is essentially running a controlled burn inside your tractor while you are operating in a dry field full of crop residue. That sentence is the whole fire risk explained. The specific failure modes. Here is where the risk gets specific, because understanding the failure modes is what allows an operator to actually manage them. Failure Mode 1. Residue accumulation around high-temperature components. Modern tractors run through heavy crop residue constantly. Chaff, dry stalks, dust, and fine organic material pack into every gap around the engine compartment, exhaust system, and emissions components during field operation. When a DPF regeneration cycle initiates, and on a hard-working tractor it initiates automatically, sometimes without the operator even noticing, that accumulated dry material around a 1,000-degree surface is a direct ignition risk. This is documented. Multiple equipment fire investigations across multiple brands have identified residue accumulation around DPF systems as a primary or contributing factor. Crop residue does not need to touch the DPF directly. It needs to reach ignition temperature from radiant heat. And at 1,000 degrees, the radiant heat radius is significant. Failure Mode 2. DPF component failure during regeneration. The DPF itself is a ceramic filter operating under thermal stress every time it regenerates. A cracked or compromised DPF filter can allow burning soot to exit the containment in ways the system was not designed to manage. If that failure occurs during a field operation regeneration cycle, the results can be catastrophic and fast. Failure Mode 3. Hydraulic line proximity to high-temperature exhaust components. Every tractor has hydraulic lines routed throughout the machine. Hydraulic fluid is combustible. In the original factory configuration, clearances between hydraulic lines and exhaust components are engineered to manage temperature. What engineers cannot engineer against is the gradual heat cycling of the mounts, the vibration that shifts component positions over thousands of hours, and the aftermarket modifications that well-meaning mechanics sometimes make to lines and fittings that move things closer to heat sources than the factory intended. A cracked hydraulic line spraying fluid onto a hot DPF surface is not a slow fire. It is an immediate, fast-moving fire. Here at Soil Frame, we cover the equipment risks that the dealership does not put in the operator's manual introduction. If this kind of honest equipment analysis is what you have been looking for, subscribe right now. Subscribe to Soil Frame. The risks nobody puts in the brochure. Why modern tractors burn faster than older ones. This is the part that surprises operators who have been running equipment for 30 years without a fire incident. A tractor built before Tier 4. Final emissions regulations, a pre-2014 machine, runs a mechanically simpler exhaust system. The exhaust exits at elevated temperature, but nothing in the system is intentionally generating 1,000-degree thermal events on a cycling basis throughout the operating day. A modern Tier 4 final tractor is a fundamentally different thermal environment. The DPF regeneration cycle is baked into the operating schedule. It happens whether the operator initiates it or the system initiates it, automatically based on soot accumulation monitoring. It happens during field operation, during road transport, during idle periods. And when it happens on a machine that has not been cleaned recently, the risk profile changes dramatically. Pre-emission era tractors could accumulate a season's worth of dust and chaff without creating a meaningful fire risk from the exhaust system alone. Modern tractors operating with significant residue accumulation around the DPF system are carrying an active fire risk during every automatic regeneration cycle. The insurance industry has noticed. Farm equipment fire claims have increased meaningfully since the widespread adoption of Tier 4 final equipment. Industry data from agricultural equipment insurers shows tractor fires as a growing loss category, with emissions system involvement cited in a significant and increasing portion of total loss events. That data trend is not coincidence. It is the direct consequence of adding 1,000-degree thermal cycling systems to machines operating in dry organic material all day. The electronic complexity factor. Beyond the emissions system, modern tractors carry a level of electronic complexity that creates its own fire risk profile, separate from but compounding the DPF issue. The wiring harness on a current generation high horsepower tractor contains thousands of connections, dozens of control modules, and miles of wire routed through a machine that vibrates continuously across rough field surfaces. Over thousands of hours, that wiring experiences mechanical stress at every connector, every routing clip, every point where a harness passes through a frame member or bulkhead. And chafed wire against a ground path, creating a resistive short, generates heat at the chafe point. That heat is invisible to any sensor on the machine. It builds slowly across operating hours until the insulation fails and ignition occurs. In a machine with extensive wiring routed near fuel and hydraulic systems, a wiring failure does not always produce a warning light before it produces a fire. Modern tractors are significantly more electrically complex than anything built 15 years ago. That complexity is a capability gain and a risk gain simultaneously. This is not a reason to avoid modern equipment. It is a reason to understand what the maintenance and inspection discipline looks like on modern equipment, which is different from what it looked like on simpler machines. What operators actually need to do here is the practical part, because identifying the risk without giving the operator actionable information is not useful. First, DPF cleaning schedule. Most manufacturers specify DPF cleaning intervals based on operating hours or soot load monitoring. Running past that interval increases regeneration frequency and duration, which increases thermal stress on the system and increases the risk of component degradation. Follow the DPF service schedule without exception. Treating the DPF service interval as optional is the most common preventable factor in emissions-related tractor fires. Second, daily residue inspection and clean-out. The accumulation of dry crop material around the DPF, SCR, and exhaust components should be part of the daily pre-operation inspection on any modern tractor operating in residue-generating conditions. This is not a weekly task. It is a daily task during harvest and heavy residue operations. A blower, compressed air, or careful manual clean-out of the exhaust system area and emissions components every morning before the machine goes to work costs 15 minutes. It removes the primary fuel source for an emissions system fire during the day's regeneration cycles. Third, hydraulic line inspection around heat sources. During scheduled maintenance, specifically inspect hydraulic lines for cracking, chafing, or position changes that have moved them closer to high-temperature exhaust components than the factory clearances intended. This becomes more important as the machine accumulates hours and the vibration-related movement of mounts and brackets adds up. Fourth, fire suppression system installation. Automatic fire suppression systems designed for agricultural equipment, systems that detect heat or flame and discharge suppression agent directly onto the engine and emission system, are a growing investment category among large operators running high-value equipment. The cost of an installed suppression system is a fraction of the cost of a total loss on a $500,000 machine. Fire suppression on high-value agricultural equipment is not paranoia. It is risk management with a clear cost-benefit calculation. Fifth, review your insurance policy right now. Specifically review whether your farm equipment policy covers total loss on a tractor, what the replacement cost basis is, and whether there are any conditions on the coverage related to maintenance documentation. An insurer who can point to a missed DPF service interval as a contributing factor to a fire loss has documentation leverage that most farmers have not thought about until after the claim. The broader equipment market implication. Here is what the Fendt fire and the broader pattern of modern tractor fire incidents mean for equipment decisions in 2026. The emissions system fire risk is not a reason to avoid modern tractors. The performance, fuel efficiency, and precision agriculture capabilities of current generation equipment are real, and they deliver real value on a properly run operation. But the risk changes the maintenance discipline that modern equipment requires compared to what pre-emission operators were accustomed to. The operator who ran a pre-2014 tractor with an occasional blowout of debris and annual service intervals is running a different maintenance program than the modern machine demands. Buying a modern tractor and maintaining it like a pre-emission machine is how total losses happen. The investment in daily residue inspection, DPF service on schedule, wiring harness condition monitoring, and fire suppression hardware is not optional on a $500,000 machine running in dry field conditions. It is the maintenance reality of modern high-horsepower equipment. The farmers who understand this going in, who budget for it, schedule for it, and build it into the daily operating routine, run modern equipment successfully across its full productive life without fire incidents. The farmers who don't are the ones filing the claims. The question for every operator. Pull out the service records on your current machine right now. When was the last DPF service? When did you last inspect residue accumulation around the emission system? When did you last physically inspect the hydraulic lines in the exhaust system proximity zone? If you cannot answer those questions with specific dates and documented records, those answers need to be on your calendar before the next working day in residue conditions. Every modern tractor in the field right now is managing the same thermal risk that took that Fendt down. The difference is whether the operator knows it and manages it, or finds out about it the hard way. Thanks for watching Soil Frame. If you found this breakdown valuable, share it with a fellow farmer and comment below your thoughts on this topic. See you in the next one.